All right, welcome to Physics 1405. Can everyone hear me?
Yes.
Okay, great. Can everyone see basically our blank whiteboard here?
Yes.
Okay, great. All right, so as a reminder, if you have any questions that you are going to ask and you want participation credit for them, make sure to make a little note in the chat because that's the record I have after this meeting closes. You don't have to put your whole question there, but just make a note of it so I can recognize it and give you participation credit. We have more people here than usual, so that's great. Thank you so much for coming. Does anyone want to get us started with any questions you have?
I'll go ahead if no one else does.
Okay.
So my question, I've done one attempt on it. I feel good about it. I know that we don't have the whole score yet because some of them are open-ended questions. But I'm hesitant about going back and doing it again and getting a worse score or just like getting more confused. So I have one question that I think maybe I might have been confused on. Mm-hmm. And it's the first question with the two students. The problem is that I feel like I kind of agree with both of them. I agree with one student more because the student talks about Stefan Boltzmann law and talks about both the size and the temperature. And the first student doesn't feel like he addresses both as much, or he just focuses on one. So then I'm like, is it a technicality or is it like very clear and I'm just not seeing it?
So it's not just a technicality, I mean, depending on how you look at the logic, but the whole point is that all of these questions that are talking about two students, right. Every single time one of them says something that is wrong, like just factually untrue, doesn't fit. So it's not a matter of one person gave a better explanation or something. Every single time there will be someone that said something that's not right.
Okay, so then am I on the right track if the one student is saying that it's the higher temperature is what's making the spaghetti cook more quickly? It's a combination of both, is it not? Or
yes.
Okay. That's where I'm like, I am certain about this, but I kind of agree. Okay, then I'm on the right track. And I feel like the quiz went well. And I feel like based on how many open-ended questions and my score, I feel good about it. If I get a worse score on the second time, would you just take the highest score?
Yeah, that's a setting in the system. And I believe it's already set to take the highest score.
Awesome. Okay. And that's where I was kind of confused, but everything else I feel like okay, but I would like to hear what other questions everyone else has.
Yeah, and hopefully, I mean, that's the whole point of, this is a lab that I think it does benefit from, our normal classroom setting where we get to, discuss and groups debate and stuff. So this is the best that we can do is have the Zoom meeting in. So I highly recommend any questions that you have, like even if you're hesitant to share, go ahead and bring them up so we can talk about them.
Okay. Oh, thank you so much.
Does anybody else have anything they want to make note of? Anybody else? I can't see hands raising or whatever in the view that I have. So feel free to just speak out if you have a question.
Hi, I have a question. On question, we talk about it in the discussion board a lot about it, but I'm just very confused about it. That which star looks redder, star E or star F? That's make me so confusing because I can't, I just figure out the star F has more redder, but on discussion board, I saw somebody just explain about it, and she said a star E has redder. I didn't get it,
Can you guys see the lab now? I just opened a file.
Okay.
Yeah, we can see
Is
it.
it visible? Okay.
Yeah.
So we're gonna move down to this. So the one with star E and star F is this first diagram. So how do we tell which color we see, like from this spectral curve? It shows a curve value for all of the different colors, right? So how do we know which one is the color that we're going to see from any given star?
I
The
think
energy
because
output.
Yeah, so the curve is of the energy output, and it tells you about all the different wavelengths, though. Here, I'm going to blow it up.
Till our visible range. So between visible range, can we figure out the energy output is higher or not?
Mhm. Yeah, it really is just a matter of reading the graph. Can you guys see these little letters down at the bottom? Down here?
Yeah.
Yeah.
So it starts with violet. So this is the high energy stuff down on the side, and it goes to red. This is low energy stuff. And so the question, this is a different question, when it says which one has a higher red output, you literally go to the R and you just follow it up. So this star has a red output this much, like where the curve is. And then this star has an output that's up here, right? So you guys can see how to answer that particular question, right?
Yes.
But for each given star, and I did make a comment, I did do a little write-up of this same concept in the discussion question, so hopefully that started to make sense. But if you look at the whole curve, where's the peak for this curve, the highest value?
The peak on.
Like you would come over and it would be in the middle here, right?
Yes.
And what color, if you drop down to the axis, what color is that?
Let's see. That's red, right?
Red.
Yes, this is the red end. So this star, so this is star E, by the way. The tall curve is star E and the bottom curve is star F. I think I had one student that, due to one of the graphs, they actually kind of couldn't figure that, like got a little confused. So this curve up here, the whole curve is star E. So where's the peak of that one? If we follow it down.
That's
Violet.
not the middle. It's on the side.
Yeah, so the V is here and it's actually to the shorter end, like even less than violet, is where the peak is. So this star is going to look, and usually they either say blue or red. So this star with the tall peak is going to look bluer, and this star with a short peak is going to look redder. Does that make sense? So it doesn't matter where the other star is or anything, you just look at the whole curve for each specific star and you decide where the peak of that curve is.
Okay.
And that determines your eyes actually blend all those colors together, and the one that's most prominent is going to be the peak color. And so that's why you see a certain color.
Okay, that makes sense. Thank you.
Yeah, and so if you look at figure B, they actually both have the same color. So they would look the same color even though they have a different energy output. What will be the difference if we look at this? What will be the visible difference if we compare these two?
Okay.
So this is just a question to like help everyone like make sure that they understand it. We're thinking through. So the difference between these, because they have the same peak, they're going to be the same color. But the one with the more output, because this is energy output that's being graphed, is going to look brighter. Now, if we come over here to figure C, there's a different area under the curve, which is actually a better measure. Like if you look at energy output, the total energy output is kind of the area under the whole curve. But we can say the peaks are about the same. So let's say that the energy output is kind of comparable, right? So what's going to be the difference between these stars if we look at them? Are they going to be very different in brightness?
No, they're temperatures, right?
Uh-huh. So from what we can tell with just our eyeballs, what's going to be the difference between these two as we look at them?
Their color.
Yeah. So we're actually going to be able to see and detect a color difference, even though, like in this case, in our first diagram, the redder star is going to be much, much dimmer because just the energy output's not very high. In this case, they got a red star that, so much energy output that it's going to have a higher curve. So it's going to be brighter. Like this red star is much brighter than this red star, but they're both red.
Right. So the difference in B, you're looking for brightness versus size. We can't tell anything based on the size, right?
Yeah. Well, we could put all of the information together. Like, for example, if we wanted to look at this one. So normally there's two things that can possibly make a star bright. If you see a bright star, you know that it's either extra, well, you tell me. And we might even go back to this one. So what are our choices for, it's going to be high, well, right, this has it independently. A bright star is highly luminous, right?
Right. Right.
Okay, so yeah, it's independent. So bigger stars are brighter though. So if we kind of go back to the burner
Okay. Right.
analogy, like you can get a hotter burner by making it bigger or making it output more.
Yeah.
One or the other, or both. Obviously, if you do both, then you're going to get the biggest, brightest one that you can get. So this one works kind of the same way.
Okay.
Okay, so that, hopefully that makes sense. And just the logic, and I wrote this up, it's part of the write-up. Oh, also, if you look, like if you compare the questions in this packet with questions as I've rephrased them on the quiz, the way that I've written them up is to help address points of confusion that people have in the past. I think there's one, I want to say it's number 16. Yeah, we've already kind of talked about that. Number 16, I can say like, is one of the most missed questions. People get it wrong all the time.
Because you're asking which one gives off more, not which one looks more red.
Yes. So literally you just go to the red part of the graph and just follow it up. And this star hits the red right here. And this star, the curve, the red wavelength part of the curve is up here. Right. So even though this star doesn't look red, it has more, like this is how much red it's putting out. And down here, this is how much red this one's putting out. So if I have rephrased the question, take that as a hint. That's why I rephrased them, is to try to like give a little bit more information about things that people seem to be confused about. So all of the quiz questions are basically exactly the same as the questions in the PAS packet. So if they look like they don't connect, you might be a little bit off as far as numbering, which I've tried to make sure to correct. So the numbers that matter are the ones that I've written in the text. The quiz has also just auto numbered some stuff, and that was actually a weird bug on Canvas. It redid it for me. But the ones that I've put in the text are the ones that should correspond. And they should be, like, if you can't understand how they're fundamentally the same question, there might be something that you're confused about that would be a good reason to ask. Because all of these, I just rewrote them to actually try to give you a few more hints in the way that they're asked. Does anybody have any other questions that they wanted to ask or concepts to discuss?
Just clarification, we get 2 shots at this?
Uh-huh.
Okay, cool.
Yeah, that's just an automatic setting, well, the way we put it. And also just take a note, I think that oftentimes I have it set so it tells you what you're getting wrong, but we try to limit that a little bit. A lot of these questions, some of them are only like two choices, like a true or false almost, or this one or that one sort of question. And so it's not going to tell you all what your wrong answers are, because basically you could switch to the other one and get credit without really even thinking it through. So just be aware, which I would recommend in any case where you're entering in your answers online. Sit down, do the packet, think about it, take notes, write, have number 1, number 2, number 3 on your paper, and decide what you think the answer is and everything. So you have a record of what you put and what you thought. And it's not like, we're working pretty hard here to not just make this an exercise and just guessing off of the multiple choices. And I know some of them don't have very many options. So that's why we're not having a heap ton of different trials at this or showing you exactly the answers at the end. Okay, any other questions? Any other points that are confusing? Okay, and I think that somebody actually mentioned this in the forum about boiling water. So back at the very beginning of the thing, I have had people kind of bring up the point, oh, spaghetti always takes the same amount of time to cook. So really the thing that matters with how much energy output you have from a burner is the amount of time it takes to boil the water. That's the amount of time it takes for a certain amount of water to boil is a constant amount of energy. So basically it's directly proportional to the energy output that the burners can put out, which is a function of how high they're on and also how big they are. A bigger burner can put out more energy. All right, well, if there are no more particular questions, I will double check the discussion group and see if there's anything else over there that we want to make sure to note. Okay, some people had trouble finding both of the parts of the lab. If you just look down at the schedule at the bottom of the homepage with all the links on it, this lab has 2 different links. So you need to open both of them, read the packet. And that's another thing. I think people tend to gloss over the reading at the beginning. This lab is all about the reading. So make sure that you do that. Okay. All right, so people were asking about the particular names of the laws. I don't think that there's any part of the lab where it's like, you have to use Wien's law or you have to use the Stefan Boltzmann law. So basically you just need to apply your logic, like the things that you know, a bigger star is brighter, you know, a more powerful star is also brighter. And then the temperature changes the color as well. So those things. And I think I also gave you guys a little bit of a write-up, just kind of simplifying. I know sometimes people look at the equations at the beginning of the lab and their eyes kind of glaze over because we don't actually make you use the equations or make the calculations or understand what all the variables are. So it's more important to understand the basic concept of brightness is proportional to temperature kind of concept, which I did make an effort to write that up separately as well. So, okay, people are asking for partners. I'm reading a little bit from the forum. Okay, yeah. So this same question was discussed quite a bit on the forum. Do you guys feel that the conversation we've had, is it clear? Is it going to make sense to people? Or do we need to elaborate? Because I saw a whole lot of people who are still confused about the same ones that we discussed. Oh, somebody did a really good, they even made the effort to post the diagram and write on it and stuff, so.
Yeah, I think with what we talked about and I did look at the discussion board, I think it makes sense because I was one of the ones that asked those questions. So it makes a lot of sense to me now, but.
Okay. All right, that's good. I think that they had a good, and I can go back. Oftentimes when somebody makes a good explanation, you know, I try to kind of endorse that or at least like it or something so people know that, hey, yeah, this person's on the right track. But it looks like there's also a good conversation about that. Okay, somebody did ask, which this is another one of the problems that is confusing way back at the very beginning when we're talking about the burners. And so The problem says for each pair of hot plates, circle the one that will do it more quickly. And if there's no way to tell for sure, state that explicitly. So for D, people sometimes try to make a guess and say, well, I think because it's on high, the little one might still beat the big one. So we want something that's sound and logical and it doesn't take guessing. So really on D, you can't tell. You know, if they were the same hot size, then the one that's on a higher setting wins. If they were same setting, the one that's bigger wins. If both of them, like in C, if both of them, like the one burner is bigger and on a higher setting, it obviously wins. For D, we can't tell which one that wins unless we go back to the equations and actually run the equation to find out. And since we don't have all the little numbers we need to do that, we really can't tell on D. I know that some people are making the point that on D, the smaller burner is really a lot smaller. So you could guess, but you would have to guess. You don't have any evidence for that. And as people have pointed out, if that one's turned way, way up, it could still win. So D is definitely a case where you can't tell unless you have the numbers. And somebody went on with numbers and started cranking them, but yeah, we don't actually have the numbers, so we can't do that. Okay. All right, I'm continuing to read through the forum, by the way. All right, there's kind of a generic question. Okay, so people somewhat were still confused about making a submission. So you don't make a file submission, but you have to answer the quiz questions, which are exactly the same as the questions in the packet, but you will submit them in the format of taking the quiz. And that's why both of the links are there right together. You really shouldn't be able to get into one without seeing that the other one at least exists. And we tried to mention that and everything, but yes, there's no separate submission, which I've tried to write that several different places, but sometimes people still seem to miss it. Okay. People are asking about the numbers. So there's actually a place in the quiz itself where I'm just like, ignore the extraneous numbers. I'm sorry, Canvas put those in there. I can't get rid of them, but just go by the text that I've actually inputted. And then, like I said, logically, you should be able to tell that the question that I asked and the question in the packet are the same one. But really, like either of them kind of should stand alone. The quiz questions, you know, should reference what you need to know for the most part. Okay, and somebody made a comment right at the end just recently that size, luminosity, and temperature are all directly proportional. That's not correct. So you can have a star just like as we're looking at figure D there, you can have a little tiny star that's super, super bright, but it's still tiny. And you can have big stars that are actually, that's actually really common. Red giant stars, which is what our sun is going to become when it's done burning, they actually cool down and expand. So the star gets super big, but it's actually dim and it's not very hot. And it goes to the redder end of the spectrum too, because redder is actually lower energy per photon. So, and kind of the point of having these, for example, the diagram that you guys had to put a star on, we call that in math orthogonal. But if you have two different variables that are on one's on one scale and one's on another scale, I've scrolled to it now. So we have a luminosity scale going up this side, a temperature scale going up that side. And you can see that a star could land anywhere on this. If there was a line that the stars were all on a line, that would mean that the luminosity and the temperature is related. And it is a little bit just that a higher temperature star usually puts out a little bit more energy, but they can be completely independent because you can also increase the luminosity of the star by jacking up the size of it, right? So you can have a star at any point on this diagram because the luminosity and the temperature are independent. You can have bright stars that are cool and bright stars that are warm. You can have, you know, any combination. And so proportionally means once you have one variable, you know something about the other variable, and it's not the case. So size and luminosity and temperature are all basically independent as far as once you know one thing about the star, you don't really necessarily know anything else. If you have the calculations, you can sometimes find relationships, but there's enough changing variables that for any given star, like these examples on these curves, you don't know one thing, if like the temperature, just because you know something else, like the color, or, well, actually you do. Those are the two things that you do know. As soon as you know the color peak, you know what the temperature is because of the, here, let's scroll back up here to the equations that you have. Your lambda max is B is a constant and T is temperature. So those two things are the things that are coupled, but everything else, you have something else that figures into it. So you can independently change luminosity, for example, the relationship between size and luminosity. You can have a big star that's dim or something like that. All right. Any other questions? Okay, I'm seeing that there were comments in the chat. Okay, did we address 21 already? Okay, star C and star E. And we do want to have this to be a conversation, a discussion. So star E and star C are these ones. So what do we know about them from looking at that?
That they would give off the same color,
Uh-huh.
but one would just be brighter than the other.
Yeah, so if they give off the same color, what does that nail down? I actually just talked about it a second ago when we scrolled up and looked at that equation.
And not about the peak. You're not asking because they peak at this.
Yes, so they peak at the same wavelength, which, looking at the equation, that depends on one of the other factors that we've talked about, which is actually temperature.
Hmm.
So we know that they're the same temperature. Let's scroll back down. So because they have the same temperature, what's the other way to jack up the energy output? Because normally if you make a star higher temperature, it will make the energy increase, right?
Right. So size?
Size.
Yes. So because we already have temperature pinned down, we can't use that to jack up our energy. We have to use size. That's the only other thing that we can really manipulate.
Okay.
All right. Okay. Okay, so I think that I don't quite understand the question about the hot plates, but let's go back and look at it and see. Okay, the two hot plates on D have a high temperature outermost. So no, there's three colors. The palest is high, the medium is kind of a middle gray, and the darkest is low. So in D, there's a small burner that's cranked all the way up to high and a big burner on medium. I'm not sure what middle 10 means, but does that answer the question about the burners on?
Thank you. I understand.
Okay, good stuff. All right, so I think that we have answered the questions in the chat. We've answered the questions we can see in the forum. If you answered a question verbally, if you asked a question verbally in this meeting and you want to make sure that I have a record of it so you get credit, go ahead and make sure that you make another note in the chat because that is what I will have. Okay, so we will close that for now. Any other questions?
Mm. Just so I understand this correctly.
Mhm.
All right. If they have the same surface temperature, so this is going back to question 10, then that would mean that X, or I'm sorry, not X. What am I looking at? 11. So question 11. So that means X would have to be a lot larger than star U because they have the same amount of luminosity, but X is obviously lower in temperature. But if there's, if you could see them the same, then that would mean that X would have to be the larger star. Is that accurate?
So they're saying it's 11?
Yes.
Yeah. So, and make sure as you look at this graph, some people assume that it goes from low to high, like, normal axes. So if you look down at here, this is 20,000 K over here. So yeah, U is hotter, X is cooler, but they have the same luminosity. So, just like we talked about before, yeah, you can change one other thing to make it more luminous. What can you change? The size. So basically X is at a disadvantage in the race. So it needs a boost in order to get back up to the luminosity, which the luminosity is pinned. You see that on the graph, they're at the same luminosity. So yeah, you have to boost the size of X to get up there to that luminosity.
Perfect.
Good logic. And then make sure to make a note in the chat if you want participation credit. Anyone else? Right. We will go ahead and turn off the recording. Go ahead, like I said, we will leave the chat open for a couple more minutes. So let any final comments that want to get in there for participation purposes get in there. But thank you for coming. The video will take a little longer to process before it's posted, but that will be up eventually. Okay. Okay. And we're getting a couple notes in the chat. Remember, I think we've already said it in this meeting. Every single student who's wrong actually makes a statement that is incorrect. It's not just skipping something. It's actually saying something that's not quite right. All right. Well, thank you, everyone. I appreciate everyone coming, and hopefully our discussion was helpful.
Thank you so much.
Thank you. Thank you.
Thanks. We'll see you.
Thank you.